LoRa technology allows data collection from sensors in densely populated smart cities or rural environments that can be up to 30 kilometers apart. Since the sensors are powered by batteries with a lifespan of up to 10 years, they also eliminate the need for power lines for sensors in GSM, LTE, or Wi-Fi networks. This means that another LoRa communication platform can provide energy efficiency as well as simplify installation. In the last 5 years, LoRaWAN-based systems have grown by 30%, with more use cases being developed every day. To date, the technology has been implemented in more than 100 countries, with more than 50 million LoRa-based devices deployed worldwide. Managing energy in smart buildings. One of the most common use cases is to use LoRa to monitor and minimize peak energy consumption throughout a building by adding sensors to thermostats, outlets, and other devices. This allows lights, water heaters, beverage dispensers, and air conditioners to be turned on or off remotely, or controlled on a predetermined energy-saving schedule. Real-time metrics support the ability to schedule tasks to be performed during low-cost periods, which helps reduce energy consumption. Better control of the resources available in each room also provides a more comfortable environment for those using the room. Making vehicles smarter. The flexibility and energy efficiency of LoRa technology is also driving applications such as parking and fleet tracking. The technology is used in parking applications that allow smart cities to combine credit card-based parking meters with remote monitoring via a mobile app. This allows field-based attendants to pinpoint specific vehicles that need to be ticketed, rather than manually checking each vehicle. This combination simplifies the use of labor while maintaining overall revenue from smart parking meters. Revenue is also protected through the use of cellular networks for card validation, which can almost have the cost per unit compared to traditional parking systems. LoRa-controlled smart lighting. By adding remote wireless communication to lighting, lights can be controlled remotely, thereby reducing energy consumption without compromising safety. It can also make lighting more ambient for large events. The LoRa gateway used to send lighting data to a server can also be used to transmit data from other sensors connected to the lighting system. For example, in the United States, LoRa gateways are used to transmit data from microphones mounted on lights to enhance safety at busy intersections. As a result, LoRa communication makes lighting smarter and more controllable, in addition to providing more functionality and reducing installation costs. All in all, the criteria for the decision process to implement remote LoRa technology are flexibility and cost and resource savings. If you know of any applications in LoRa technology, please share your ideas in the comment zone.